This is a video just to show you how to do that assignment task on the geometry development. This is the drawing that you need to complete, and what we need again to look into planning to complete this particular drawing. As I said to you that we spend some time just to understand or interpret the actual drawing, then we can start producing it. There is not much annotations on this drawing, but we'll try to complete as much annotations as it can. Please don't worry about the title block at this stage. So if I come back to the actual drawing, so here you know that this particular geometry development is actually for a sheet metal. It's a cold rolled sheet metal. Generally you get it as a rectangle, as in the case the minimum rectangle required, rectangle size, the minimum rectangle size in terms of the width and the height is, the width is actually the perimeter of the circle that goes into 13 divisions here. The height is basically 200. So if you look at it 100 there, the perimeter of a circle or a circumference of the circle will be 100 multiplied by pi, which is basically 3.14. so that will give you 314.15 into 200 is a minimum rectangular sheet that required. So generally what happens in the fabrication office is that you know that minimum sheet size. Then once you get this profile 1-to-1 onto the sheet, then you get your points. As you get your points along the spline, then use a punch hole to get those intersection points. Remove the sheet and cut the sheet metal along the curve and fold it to get a tube-like section. But this is actually a tube with a section of angle 35 degrees. 35 degrees here means it's actually 90 minus 35, 55 degrees here. So we'll use a couple of options in terms of arrays, multi-line text arrays. Then this is a polar array. We'll use a point options to insert the points with specific shapes. So in this we use a cross shapes. We also have to do a lot of trimming as you extend horizontal and the vertical lines to meet the array divisions on this side of the view as well. So this is the actual geometric development which we will develop using the intersection points and apply a spline option on it. So come back to AutoCAD. So first thing would be select a circle. So select a circle, just activate your grid, pan into it just very close to the origin somewhere. So we'll snap the intersection here. It's asking for a radius, so your radius should be 50. Then you can remove your snap setting off. Careful that in this case we'll use a lot of snap references, and also make sure you select majority of the object snaps. Critically you will be using quadrants and so on, so just select all of them, click OK. Now you select the polyline because I wanted to draw it as a one line, so you can select the quadrant, snap to the grid intersection. If you want to grid intersection, activate again grid intersection, so you got your grid intersection there, and you can deactivate your grid intersection. You want to go vertical like this, what you need is again activate the ortho option, so you go 200 this way, and now deactivate your ortho because you want to subtend some angle. Press tab key just to make that angle 55. Don't press enter, tab again, because you don't know the approximate length how it is going. All we know that it stops at the alignment of this end of the circle here. So you can infer that end by clicking into the quadrant and coming back to find the inference line there. So you can snap now. So as you're moving, so you can see the inference there. So that should be fine. Snap there. Again, find the inference horizontal line, and that way you lock you lock the vertical line. If something is happening that is not going a straight line, just activate the ortho. Again, go and find the inference. It will lock you for the intersection. Lock it back here. So that completes the section of that particular tube. The next would be rectangle. I would recommend you to use a calculator here. Just type cal. Once you type the calculator, sorry. So that's the calculator. In the calculator, what I want you to calculate would be your pi value multiplied with the diameter. So that's diameter into diameter is 100. So that gives you a value of you can use the 314.15 for the one side of the rectangle. Select the rectangle, snap to the intersection. You got an inference here. If you want to use a grid again, just go to the grid and activate the grid. So you're going this way, rectangle, so this should be 314.15 tab. That length should be 200. Enter 200. So that's your rectangle. And next thing would be explode this. Type explode command. Explode this one. You will not need this line because you're doing 13 divisions using a rectangular array. Select this one and apply a rectangular array. You'll have options of path array and a polar array. We'll apply polar array on this one first, rectangular array. So it's a linear extension, so you don't want any rows in this case. Just apply one rows. How many columns you want? You want 13 columns. Total length of the is 314.15. that one we calculated using a calculator, so that will give you around 26 distance between each of them. Then you can close your array. You got those divisions that you wanted, and what you can do is you can simply explode them by typing X. It just exploded, right? So you got those lines. You need to explode them because you'll find an intersection along the horizontal lines with these vertical lines. So go into utilities, point styles, make it a cross, set it to absolute, and see and put a point PO. Once you put a point PO, you snap that there. That's a point there. Once you snap it, select that point and apply a polar array with a center specifying that center. So in this case you want 12 divisions over 360. So these options, in terms, if you're looking at a lesser angle, sometimes the direction will be important. If you're making 270 and the direction might make a difference in which you want to rotate, right? So that might change depending on the direction as well. So but in this case it is 360 equal divisions, so direction doesn't really matter. So that's with the polar array. You really need an axis or a center point. So once you got a polar array, select the lines, snap to these intersections that you got to extend the lines. So extend the vertical lines. Keep your ortho active. Keep extending the lines from here. Keep extending the lines because so keep extending the lines. Because object snaps will play around with you, but just be careful with that. I will also delimit the grid, so it's easy. Select the lines and snap it here. Once it is snapped, you can bring back this one to here, and so what I'm doing is I have got an extension and I'm finding an intersection on that slope line. So we got the vertical lines ready to be extended further as horizontal towards the rectangle. So just find the perpendicular snap and do all the intersections. So in this case, I think to make it simple, you can also extend up to 6 points this one. So this should be fine here as well. So 1, 2, 3, 4, 5, 6 divisions. So there's a 6 snaps there, so you can extend from here to there's a 6 snaps. So yeah, this will be fine. So delete this line as well, so we can extend the very top line up to the sixth point, and you can extend this one to the midpoint, or maybe it's better that you extend it to the end. That's okay, just to find all the intersections. So extend. So keep extending the lines up to it snaps to perpendicularity. Press escape, snap again, find the perpendicular intersection. This should be fine as well. So you can extend this one as well, the bottom one. Once you extend, you can apply the spline, which is SPL. Enter SPL, snap the points and keep joining the points. So this will go and create a fit curve for that intersection points, and you can press enter and use a mirror option to select the object, enter between this point and this point. So that completes the spline. Mirror, select the object, enter. So you specify the start point and also the end point of the line, and you should specifically say no to image, mirror image. If you say no to erase the source object, it will remain the source object. Fine. Next, you can apply the trim lines. You can select the entire objects and apply the trim. Apply the trim. In this case, why it's not trimming? Or you can apply. So you really want to do the intersection of that. It's a delete I was using. So this one, trim, and you can select the trim object. So that way you can trim the objects. So you can trim the portion that you got here by trimming the objects. Okay. So you can eliminate the lines that extend beyond the arc. You really need to stop at the curve intersection here. Last thing here would be your annotations or multi-leader lines. You can select the text, which is of a 5 mil. If you don't have 5 mil, you can just include the multi-line text here. Once included, I think in my case 5 mil is too big. Select the multi-line text, and so there should be starting with 0 there. If your text is too small or too big, you can type the property PR and bring the text height to some scale that fits to your drawing. So text height, annotate text height here. I'll remove this one, no, and standard one is too big as well, so may add the scale. This one maybe 1 to 4 should be fine, and I'll delete the 1 to 16. That should be fine. So close this one. So once you got that one, it will be better that you want to center that text. You center that text, and if you need any special symbols, you're hitting it from here, the special symbols, so your diameter, plus or minus symbols, all that. So this one should go apply, move this one to remove the ortho option, and I just want to center it with the line. Once you line it, it's easy. Just now again apply rectangular array, 1 rows, and this should be how many? 13 of them, and the overall length should be 314.15. So that will fit at the center now. Once it is centered, you can close the array and select again, explode that one, and keep editing the text. So this should be 1, and so on. So that's how you can complete the geometric development exercise. Good luck. Thank you.